Let's look at section 4.3, which is on functional groups. What is a functional group? Basically, a functional group is anything that changes the function of a molecule, right? Now, practically speaking, for something to be considered a functional group, we need a carbon multiple bond and or a heteroatom. All right. Now, what is a heteroatom? Heteroatom is anything that's not carbon or hydrogen. So there are a couple of these that we're going to talk about. The table 4.4 in your textbook gives a whole bunch of these, and several of them are spread out actually through several other chapters. So we're going to look at those more in detail there. But anyway, first thing though that we had look at with this is something called our functional groups containing something we call a carbonyl. Right? Carbonyl is a carbon double bonded to oxygen. Carbon double bonded to oxygen. We have a couple of these that we talk about. First of these is the aldehyde, which is a carbonyl carbon that has at least one hydrogen on it and typically is bonded to another carbon. This is called the aldehyde. Okay. Then closely related to that, but not quite the same thing, we have the ketone. All right. Ketones have the carbonyl carbon bonded to two other carbons. Also in this, we have the carboxylic acid. Excuse me. Carboxylic acid, carbonyl carbon bonded to an OH. We have the ester, which looks like this. Then we have the amide, which is carbonyl carbon bonded to a nitrogen. Now, more broadly, among our oxygen-containing functional groups, we have alcohols, which are COH. We actually have three different types of alcohols we're going to look at. First of these is called the primary alcohol, where the carbon that the OH is on is only bonded to one other carbon, or put another way, that it has two hydrogens on it. It's primary. We have the secondary alcohol, where our OH carbon is bonded to two other carbons. And then, of course, tertiary, where our OH carbon is bonded to three other carbons. Also, in our oxygen-containing functional groups, we have the ether. Which is COC. Pardon me. Then our last one that we're going to talk about with our heteroatom functional groups are going to be our nitrogen containing ones, or specifically, we already talked about one of those, the amide. So we are going to talk about amines. Amines contain a carbon bonded to a nitrogen. That nitrogen can contain or can be bonded to two hydrogens, in which case this is a primary amine. Can be bonded to one carbon and one hydrogen, which would make this a secondary amine, or it could be bonded to 3 carbons total. Makes this a tertiary amine. All right. Now, let's look at our carbon-carbon double bond functional groups. All right. These are called alkenes. Okay. Alkenes. Alkenes we actually name quite a bit, or very similarly to alkanes, but there's some peculiarities to them. All right, 1, 2, 3, 4, 5. This would be pent, but because it's an alkene, we ended in ene. But of course, there's always the question of, is this the same as this? Which is the same? Is that the same as that? Of course, the answer is very much a no. So we would call this 3-pentene. The double bond starts on carbon number 3. This would be 2-pentene, and this would be 1-pentene. But that's still not the whole story with this, right? Now, let's look at 3-pentene specifically. And let's look at 3-pentene as I've drawn it there. And let's look at it like this. All right. Sorry, that's 2-pentene, not 3-pentene. I made a mistake on this. These are the same thing, right? 1, 2. This is 2-pentene also. All right. Anyway, let me continue with that point, though. Let's draw the double bond. Let's draw it like this. Do we think that there is a difference between these two? The answer is actually yes, there is. We will do, the next time we meet for lab, we will do a lab with molecular models where we actually play with double bonds and see this. But double bonds actually are rigid. We can't rotate them like we can single bonds. And so these carbons are rigidly locked in this orientation relative to each other, just like these are rigidly locked relative to each other. So if we look at this, these carbons are on the same side of the double bond. Because of that, we are going to use the prefix cis. This is cis 2-pentene. This one, by the way, is actually trans 2-pentene. Right? So that's cis and trans isomers with alkenes. Okay. Cis and trans isomers with alkenes. Now, our last functional group that we're going, no, sorry, we have 2 more to talk about here. Second to last one is the alkyne, which contains a carbon triple bond. This, incidentally, is our simplest one. This is called, this would be called ethine, or has a common name of acetylene. All right. But basically our naming rules for this work just like they do with alkanes and alkenes. We do not have cis and trans isomers, but all right, this one. This is a 2, 3, 4, 5, 6, 7. That's going to be 7. So this is going to be heptyne. 1, 2, 3, 4. 1, 2, 3, 4. So this is going to be 4-heptyne. All right. 4-heptyne. Now, our last functional group that we are going to talk about is the aromatic. Which, if you were taking a formal organic chemistry course, this would be an entire chapter in and of itself. Aromatic compounds actually are quite a bit more complicated than we're going to teach them in here, but essentially our stereotypical aromatic compound is something called benzene. Benzene is a 6-membered ring with alternating single and double bonds. Has the formula C6H6. Now, we can have substituted benzenes. Oh, first of all, let me see this. Okay, so it's actually a little bit fudging to call these single bonds or double bonds. They're really kind of a bond and a half. If we taught resonance structures in this class, this would be a great place to talk about them. But really, they're kind of neither a single bond nor a double bond. So when we draw this as a skeletal structure, this is one way to draw it, but this is actually another completely correct way to draw it, and one that I actually prefer. But in any case, now we can have substituted benzenes. We could have something like this. This is a compound called toluene. We're not going to worry about how to name these though. But there is one specific functional group that we are going to worry about in the context of this. This is benzene with an OH hanging off of it. This specific compound is called phenol. But more generally, benzene rings with an OH on them, even if there's other stuff attached to them, are called phenols. We will do a lab where we talk about phenols the next time we meet for lab. But anyway, that takes care of section 4.3.